mole is a unit of what? It is a unit of measurement, okay? It is a unit of measurement, and what does it measure? It helps us to measure the number of particles. It helps us to measure the number of particles in 1 mole of a substance, okay? Now, what are these particles that we're talking about? So the particles that we're talking about is, or they are atoms, we have molecules, we have ions, and finally we have electrons. So the mole is a unit of measurement of the number of particles in 1 mole of a substance. And these particles are atoms, molecules, ions, and electrons. So the mole, or these particles, are represented, or the numerical representation of the particles is, we say in 1 mole, and the mole can be written as N. So in 1 mole of a substance, we contain 6.023 times 10 raised to power 23 particles. Okay? In 1 mole of a substance, you have 6.023 times 10 raised to power 23 what? Particles. Now this number is what you refer to as Avogadro's number, or an Avogadro's constant. Okay? An Avogadro's constant. So what does this simply mean? It means that in 1 mole of a substance, we have 6.023 times 10 raised to power 23 atoms, okay, ions, electrons, or molecules. How many atoms are present in 0.2 moles of magnesium? So what do? You say in 1 mole of magnesium, you have how many atoms? You have 6.023 times 10 raised to power 23 atoms. Okay, so how many atoms are going to be present in 0.2 moles of magnesium? And then you cross multiply. You say 0.2, you multiply by 6.023 times 10 raised to power 23 atoms. You divide by 1. There you had moles, that is moles also. You divide by that, the mole cancels out with the mole. When you multiply, how many atoms are you going to get? Yes, you're going to get 1.24. You multiply by 10 raised to power 23 what? 23 atoms. Now, how many atoms are present in 0.5 moles? How many atoms are present in 0.5 moles of calcium? What do? You say 1 mole of calcium contains 6.023 times 10 raised to power 23 what? To power 23 atoms. So how many atoms are going to be present in 0.5 moles of what? Moles of calcium. What do? You cross what? Multiply. You say 0.5 moles. You multiply by 6.023 times 10 raised to power 23 atoms. You divide by 1 mole. The mole and the mole cancels off. You multiply it and you get how many atoms are present? 3.0115 times 10 raised to power 23 what? To power 23 atoms. So that is how you calculate the number of atoms present in a substance. So let us talk about molar mass. What is molar mass and how do you get this thing that we're calling the molar mass? So that is how you abbreviate it, MR. capital M, small r. So what is molar mass? Molar mass is the mass in grams of 1 mole of a substance. The mass in what? The mass in grams of 1 mole of a substance. How do you get the molar mass of an atom? Let us talk about sodium. Sodium is written as Na. You put 11 there, that is the atomic number. We said it's normally the subscript, and then the superscript is the mass number. So the molar mass of sodium, it is the mass of sodium. And this is what we say, it's the mass. This is the atomic number. So 23 grams. So 23 grams per mole is the molar mass of sodium. And this molar mass is normally given in the periodic table. Okay. Now, when you're talking about an atom, the mass of an atom is what you call molar mass. The mass of an ionic compound. This is for an atom. When you're talking about an ionic compound, when you're talking about an ionic compound, the molar mass of an ionic compound is referred to as the relative formula mass. Relative formula mass. For example, let us talk about a substance that we call iron 3 chloride. So what is the molar mass of iron 3 chloride? So iron 3 chloride is an ionic compound, so we talk about relative formula mass in reference to ionic compounds. What you do is you come and check again the mass number of these elements in the periodic table. If it is a question, you're normally given the mass on the side. So that shouldn't worry you how you're not supposed to cram or anything. So for example, for iron, the mass of iron atom is 56. Okay, so what you're going to do, you're going to take the mass of iron, which is 56. You add the masses of 3 chlorine atoms. So chlorine atom has a mass, so you're saying iron has a mass of 56 and chlorine has a mass of 35. So it's going to be 56, you add 35 for the first chlorine atom, remember there are 3, plus 35 for the second chloride ion, and 35 for the third chloride ion. Now, when you add them, you get 162 grams per mole. That is how you calculate relative formula mass of ions. Now, let us go to molecular compounds or molecules. Remember, these are the particles that we were talking about, the atoms, ions, molecules. And we said these particles, we say that in 1 mole of a substance, you have 6.02 times 10 raised to power 23 particles, atoms, ions, molecules. So when you're talking about the mass of molecules, we refer this as to the relative atomic mass. We say R.M. For ionic compound, we say R.F.M, relative formula mass. For molecules, we say the R.M. So what do? An example of a molecule can be like oxygen atom. Like oxygen is, you have 2 oxygen atoms combining to form your oxygen molecule. You even have what? Chlorine gas. Chlorine is also diatomic, so you have 2 chloride molecules joining to form your chloride or your chlorine gas. So chlorine is an example of a molecule. So when told to work out the relative atomic mass, what do? You again go back to your periodic table, you check the mass of 1 chlorine atom, or you'll be given there in your question. So the mass of 1 chlorine atom is normally what? It's 35. So how many chlorine atoms do we have here? We have 2. So the relative atomic mass of chlorine gas will be 35 plus 35 to give you 70. Okay, now so it would be 70 grams per mole, because we have said that the molar mass is the mass in grams per mole of one substance.